All right, this is our first video on graphing sinusoidal functions, graphs of sine and cosine. And then at some point, either in this video or in the next one, we'll get to tangent as well. The first thing I'd like you to do is take a look at the basic unit circle sort of sketch I made over here with our quadrantal values for cosine and sine. So that would be like the 1, 0 and the 0, 1. The x value is cosine and the y value is sine. And then the signs, whether they're positive or negative, throughout the four quadrants there. The other thing that's going to be useful for us is what the sine and cosine values of pi over 4 are. Well, the sine and cosine of pi over 4 is the same value. It's the square root of 2 over 2. That value is going to pop up quite a bit here as we're graphing these. So we're going to focus just on the sine values here, because we're going to just look at y equals the sine of x. So let's just do the quadrantal values first. So we're talking 0, pi over 2, pi, 3 pi over 2, and then 2 pi. So we're just looking at these values as we're going around the circle there, the unit circle. So the sine of 0 degrees is 0. The sine of pi over 2 is 1 from right here. Sine of pi is also 0. 3 pi over 2 is negative 1. And then 2 pi is really just the same thing as 0. And that's just 0 again. We could continue this table on forever. This function is periodic. It goes on forever and continues the same y value patterns as it goes. So now we'll take a look at the other values in this table, which are all values that have pi over 4 as a reference angle. So the first one is just pi over 4 itself. So that's going to be the square root of 2 over 2. The sine of pi over 4 is the square root of 2 over 2. 3 pi over 4, now we're in the second quadrant. So we're looking at this angle right here. It's got a reference angle of pi over 4. So we know the value is the square root of 2 over 2. Now it's just a question of whether it's positive or negative. Well, sine in the second quadrant is positive, so we're going to leave that value positive. In the third quadrant, 5 pi over 4, our value is negative. And in the fourth quadrant, 7 pi over 4, which is right here, our value is also negative. Okay, all of these have a reference angle of pi over 4, which is why we have the square root of 2 over 2 as our value, and then the positives and negatives just change as we go. The 9 pi over 4, well, if you think about where that is, that's just pi over 4 again. 9 pi over 4 is just pi over 4 again. So I just repeated those first two values just to show that we continue with this. Those values continue to repeat. So on the graph that we have here, we're going to make this value on our y-axis 1 and this value negative 1. Which means we have 0.5 right here and negative 0.5 right here. The other thing I'd like to point out is the square root of 2 over 2 is about, and we've seen this before, about 0.707 to the thousandths. So that's going to be right about here on our y-axis. And then negative square root of 7, I'm just kind of guessing where this is here, is about right there. It might be a little low. That's negative square root of 2 over 2. All right, so let's start plotting these points here to find out what this graph looks like. So the x values are the angles. The y values are the actual value of the trig function. I guess before we do that, we should probably scale out our x-axis. Okay, the angles on the x-axis. Well, we definitely want to go from 0 to 2 pi. This is really important. It's a good idea when you're graphing these functions to split your graphs at minimum into fourths, and if you can, into eighths. So let's see, we've got 1, 2, 3, 4, 5, 6, 7, 8 lines going right there. What a coincidence. I'm going to put 2 pi right there. I'm going to put pi right here, pi over 2, and that would put 3 pi over 2 right there. So I've split it into fourths the way that it is right now. I'm also going to take the time on this graph to label our angles in between here. That would be pi over 4. So we'll zoom in here a little bit. This would be 3 pi over 4. This is 4 pi over 4, so 5 pi over 4, 6 pi over 4, and then 7 pi over 4. We won't always get that detailed, but I think on this first graph, that's not a bad idea. All right, I'm just going to stay here, but if you want to, you have the ability to look at that table to your left too. We're just going to start plotting those points. We said the sine of 0 is 0. The sine of pi over 4 was that square root of 2 over 2. The sine of pi over 2 was 1. And I'm just going to continue on here with these points till I finish what's called a full cycle of this graph. So our maximum value of our function y equals the sine of x is always 1. So this is, we will never go above this line right here. We will never go below -1. Try that again. We will never go below that line. And then we have that square root of 2 over 2 line that we're also going to be using to get more points. But the graph of sine just bounces back and forth between those two lines that I just put there at 1 and -1. So this is what sine looks like. Actually, I'm going to go back one more value here. Just want to move that out of the way. There we go. I'm going to go back one more value here at -π/4. We know that this pattern would continue. The sine of -π/4 is the same as the other angle that's in the fourth quadrant. That's 7π/4. They're coterminal, so that would be right here. So just so I have another point to go through here. This is what the sine function looks like. Okay. And if I were able to go back even further, I would end up having that minimum value of -1 there. Okay, we don't have to really fit that on there, but just to know that it goes forever in both directions. There is sine. So if you have a minute here, what I'd like you to try to do, and you pause the video, is to fill out this table using the process that we just did. Okay, so pause the video, try to fill that table out, and then we're going to start scaling this graph out as well. All right, so I took a second there to fill the table out. Notice that that our values for square root of 2 over 2 are now negative in different spots because cosine is negative in the third quadrant and it is negative in the second quadrant. I'm sorry, that is the second quadrant right there, quadrant 2, and it is negative in quadrant 3 as well. That's why those two values are negative. Cosine is positive, obviously, in quadrant 1 and positive in quadrant 4. So we can scale our graph out. If you haven't done that yet, make sure you do that. It's the same as the scale above, and we can start plotting these points in. At 0, we are at 1. I'm going to graph this one a little bit different way. I'm going to start at the maximum. I'm going to draw this full cycle the way that I normally would draw one of our example problems or a problem in the homework. I would, when I'm drawing one cycle, know that wherever it starts, it's going to end at that same spot. Okay, that constitutes a full cycle. The cosine graph starts at its maximum and it ends at its maximum. That means halfway through, it will hit its minimum value. So right there is the minimum value at -1. Between those values, the maximums and minimums, it has x-intercepts. Okay, and all these things are true for sine as well, or not all these things, but the idea that where it started, right there, is where it ended. True for sine as well. Okay, between those points is its x-intercept, and then between the x-intercepts you had maximums and minimums. Okay, so kind of that same idea holds true. You got your maximums, minimum halfway between, and then between those you have your x-intercepts. And then the only thing that we need to add yet are those square root of 2 over 2 points. So I'm just going to kind of guess where the square root of 2 or 0.7 is, right about there. And then we could fit our other points in there at π/4 and all the other angles that have π/4 as its reference angle. So we'd come down here into the negatives. All right, so we're ready to draw one cycle of this cosine function here. So I'm going to go through that maximum and the x-intercepts and the square root of 2 over 2 points until I hit that maximum there. All right, so these graphs should look pretty similar. Okay, they should look like, what is going on here? They should look like if I pulled one of these graphs left or right, that it would look exactly like the other one. In fact, the amount that I would have to pull one left or right would be π/2. For example, if I took this graph right here and shifted it left, π/2, it would look just like that cosine graph. If I took the cosine graph and shifted it right pi over 2, it would look just like that red sine graph up above. That's kind of important. So these are the parent functions. So let's talk a little bit more about some of the terminology that we need to know. These functions are both periodic. Periodic. Let's make sure we're spelling things correctly here. And that means that there's a repeating pattern that continues indefinitely both directions. The domain of both of these functions is all real numbers. Put anything into them. The shortest repeating pattern is called a cycle, and the length of that cycle is called the period. Really having trouble spelling that word period today. There we go. The period or length of one repeating cycle of both of these functions is 2 pi. Very important concept. These parent functions repeat their y values every 2 pi. Now the range of both these functions is not all real numbers. They both go from -1 until 1 inclusive. And the amplitude is half the distance from the minimum to the maximum. In other words, it's the distance from this, what I call a midline right here. Okay, I call that the midline. The distance from that midline to the maximum, or the distance from that midline to the minimum, is called the amplitude. Okay, and it's a distance, so it doesn't matter if it's going up or down, or positive or negative. The amplitude is 1. The amplitude of both of these functions is 1. All right, let's take a look at a few more important ideas here when we start changing the values. So we just did y equals sine of x and y equals cosine of x. Now we're going to have vertical stretch or vertical strength, and that's the a value. So that a value then is going to affect the amplitude. The amplitude is always going to be the absolute value of a. The period is going to be given to us by that b value. The way we find the b value is by taking 2 pi over the absolute value of b. That'll give us the period. So if you think about in our last functions, a and b were both 1, which is why the amplitude is 1, absolute value of 1 is 1, and why the period was 2 pi, because if you put 1 in for b, you would get 2 pi. The 5 key points contained in the cycle are the minimum values, the maximum values, and then the midline intercepts. There is 1 minimum for sine, 1 maximum for sine, and then 3 midline intercepts for sine. Cosine has 1 minimum value, 2 maximum, and 2 midlines. Okay, not really something you need to memorize. It's going to be something that you're just, the amount that we do these, you're going to get pretty used to that idea. And then we also found those square root of 2 over 2 points. Well, if we vertically stretch this graph with a, then those square root of 2 over 2 points are also going to be affected by a as well. We'll just take a and multiply it by the square root of 2 over 2 in order to find out where those points are. And then I just put here, since the square root of 2 over 2 is about 0.7, that means that those points are going to be about 70% of the amplitude. And then down here, I just put examples of that sine and cosine graphs again, not putting in the square root of 2 over 2 points, just some pretty general sketches. And here we're going to talk about how we will sketch these things. All right. The first thing that we're always going to do is find the period and then put it on the x-axis. So this is kind of the order that we would graph one of these functions in. First, I would find the period, and I would put it on the x-axis. Okay, so I'm going to pretend we don't have like a grid. It's just this plain graph that we're going to use here. So whatever the period is, we're going to put it out here. So that would be whatever 2 pi over the absolute value of b is. Then we would split this into fourths. The easiest way to do that is to cut that in half. So you're trying to keep this to scale. So you're going to cut that in half. That'd be about right there. Maybe a little bit right there, okay? So this, we could figure out what this is. If you're dividing this by 2, this would be pi over b. But I'm just going to say that this would be the first thing that you do. This would then be the second thing that you do. And then the third thing I would do is cut that in half. And then find this guy right here. Okay, then use that scale that you just put on the x-axis to help figure out how you're going to scale your y-axis. All right. For example, let me just go back up to our problems that we started with here, the parent functions. When I put 6 pi, right, or I'm sorry, 2 pi right there, which is about 6.28, right, 2 times 3.14, and when I put pi right there, which is 3.14, I was kind of thinking about, how big that is when I put the 1 right there, all right? To me, it's a little big, obviously, but I wanted us to kind of see this graph, uh, you know, zoom in on it a little bit. So it's not really to scale all that much, but I did a better job than just if I would have gone like, oh, here's 2 pi and there's 1 right there. That doesn't make a whole lot of sense because 2 pi is about 6, and to say that that's about 1 doesn't make much sense. So we're going to try to keep these to scale as much as possible. So without knowing what an actual a and b value are here in this generic example I'm making, I'm just going to put, you just got to come over here and put whatever a is, and then this would be whatever really the opposite of a is right there. All right. Now would actually be a good time to look at the second 14.1, 14.2 video because that's when I go through some of the examples that we have that go along with these notes. There's no examples actually in this notes packet. There's a separate sheet so we can kind of look at both at the same time. Well, that's a separate video. So check out the 14.1, 14.2 video number 2 and get some of those examples done as well.